Here's a 1-year roadmap to become a computer vision engineer. You can probably even do it faster if you put in more time, and also if you already know some of the fundamentals from the start. This is a full breakdown. If you're starting off from scratch, you're never taught computer vision, even coding before, then you can just spend 1 year with this roadmap here and you'll become a computer vision engineer. There's no reason to spend 5 years for a university degree where you learn all the fundamentals, all the theory and so on, because again, with the direction where AI is going now, it's way better to have self-learning, use the AI models, use the large language models to learn faster. You just need a structured roadmap to get to your destination as fast as possible. It's really hard to navigate if you get into a new area, into a new city, you're driving around, you don't have a map or navigation. It's pretty much impossible to reach the goal or the end destination. So it's way better to have mentorship, guidance, and then also basically just have a plan where you want to go, because university degrees, they're too general and so on. They're very outdated. Even when I got one, it was before large language model, ChatGPT and so on. Teaching was outdated back then. Then you can even imagine how outdated it is now. If you're just getting into an AI, computer vision, data science degree and so on, I can't even imagine getting out in 5 years, because the value of coding is basically just going towards zero. It's way more about building systems, building software and so on, but we need to have a fundamental understanding, commit to it, use this 1 year roadmap while you're building all the other stuff on the sideline. We're going to break it down month by month, what you need to do, all the skills that you need to do, the tools that you need to learn, frameworks, the different projects that you can create month by month, but also very important, put your work out there, focusing on, act like building a network, getting opportunities once you're done with the roadmap and you're a computer vision engineer. Because most people, they just learn stuff and then they get started with the work, the experiences and so on. Once they get into a job, then they're basically just stuck there in junior positions and all that, which is going to be replaced by AI and is already being now. If you just sit back, think about it for some time, just look out the window, think about where is AI heading, then just imagine in 2, 3, or even 5 years, no one is going to code. It's going to be way more about knowing the different tools, knowing what's possible, how to connect all the components together, prompt, supervise the systems, but we still need to learn the fundamentals on a higher level. We don't need to dive fully into the math or like fully into a very specific area, because the large language models can help us with that. So the first month, if you're starting off from scratch, you can skip ahead and so on. I'm going to have the timestamps for each month and also the different areas that you have to learn in this 1 year roadmap. This is probably the best structured roadmap that you can get. I've not seen anyone out there put out this computer vision roadmap as detailed, and basically just, this is not a quick get rich quick scheme or like get a job in 2 weeks. Just watch these videos, courses, and you will get a job in 2 weeks. This is commitment for months and even like a whole year, depending on where you're starting. If you already have like math fundamentals, if you know Python, if you know some basic image processing, maybe you know some update detection, YOLO models and all that, then it's gonna be faster. Also depends on how much time you put into it. But 20-30 hours per week if you study this full time and just have hands-on practice, hands-on experience, and do projects alongside, but also like build your network, build your personal aspects and so on, as well as I'm teaching inside the AI career program. Mentorship is probably the most important thing when you're doing this here. You don't need a university degree. You can take a roadmap, find all information on YouTube in different courses and so on, have a mentor helping you out, answering questions that you might have, making sure that you go in the right direction, because this roadmap here might not be tailored specifically for all people, but again, this is a general roadmap, and then it can be narrowed down depending on where you want to go. So I have the AI career program if you're interested as well, where we basically have like a full community, AI, machine learning, computer vision, and so on. We have all my technical courses, all my business, personal courses as well, online marketing, pretty much like personal branding, freelance work, how do you build your own freelance business as I did. I give you my whole system, how to land AI, machine learning jobs and all that. All the pillars are combined in there, even how to stay up to date with the newest AI tools. But the most important thing of all is the mentorship. If you combine the roadmap here with the mentorship, there will also be a discount specifically only for this video down in the description, so definitely check that out. For the first month, we need to learn Python and math foundations. You don't need to be a math genius, but when we're working with computer vision compared to other machine learning NLP, AI fields and so on, we actually need to know some math. Of course, you also need to know some math in the other fields, but when we actually use the models and all that, it's way more important to know math, some linear algebra and all that when we're working with images, because we need to know some math on top of it. When we have an image, it's basically just a 2D array with pixels, like a coordinate system, and then we can do a ton of different transformations. We can do some filtering, statistical methods and all that. So the most important things when we're starting out is master Python. You probably already know it, but again, also specifically for computer vision. So we have some frameworks like NumPy. You need to ace NumPy, and you also need to ace OpenCV. Those are the two main frameworks in computer vision, just for handling, doing image operations, doing math calculations and all that. Then we have some other frameworks like Autolytics, RoboFlow and all that, tools for generating models with pretty much like object detection, image data set, the deep learning, machine learning aspect and so on of it. But there's so much more to computer vision with the traditional computer vision algorithms, methods, pre-processing, how we handle images, synchronization of cameras. So we're also dealing with a lot of hardware when we're a computer vision engineer. So learn essential math, linear algebra, calculus, and also probability theory, NumPy, OpenCV. You need to master that. Of course, you will get way more experience. You will learn coding and so on also in the other months, but make sure that you have some foundation of Python and also the math foundations when you're starting out in month 1. So some basic image processing projects that you can start out with after that, like grayscale, like how do you grayscale an image, what is an RGB image, what is grayscaling, some simple filters, how can we do pre-processing to our images, how can we blur it, how can we sharpen the edges and all that. Learn that while you're learning Python and also OpenCV. Most of you guys watching this video here probably already have some coding experience, so you'll already be set for this one. Another good one is just software engineering in general. Learn software engineering, data structures, algorithms, and then again, keep building on top of it with OpenCV. I have tons of resources on my YouTube channel covering everything in computer vision that you need to know. Also on my GitHub, I have a repository going over 25 different topics in computer vision. So use that GitHub repo together with this roadmap here, and then have mentorship on top of it. Big O notation, hash tables, trees, recursion, all different types of data structures, but also algorithms like different sorting algorithms. You can just prompt the large language models to come up with methods, but you need to make sure that you understand which one to use in different scenarios. Yes, maybe you don't need like hash tables or like different trees or recursion functions and all that when we're specifically just working with computer vision, but it's just coding experience, coding knowledge in general. You just build a foundation, and then there's ways to learn things, but also navigate. Also, because computer vision is not just solving math or something like that. If you want to be a computer vision engineer, get projects out there in the real world, we need to know how to build software systems around it, but that's for another video on like building on top of it. So we need to learn some of that. We need to go in, start to implement some image transformations. We have some affine transformations, homography transformations, how we can create bird's eye views, do basic transformations. This is also math, so how are we moving both objects, images and so on around. We can start to get into some camera calibration. How is that working under the hood? How can we get best camera calibration? What affects the different parameters? And to do that, we need to know the fundamentals under the hood. Filtering, thresholding, so how do we threshold an image? That is some pretty awesome stuff to do as well. This is still on the basic level, but you'll keep doing that while you're just learning the algorithms and so on. So start, just get a good foundation of coding. OpenCV, reading documentation. OpenCV's documentation is not good, but if you learn how to read OpenCV's documentation, you will pretty much be able to read any documentation. It's technical, detailed, and so on as well, so you will also learn a ton from that. Then in the next month, or for each of the month here, we should also have a project. So for this one here, you can probably just come up with a photo editor to create like a very basic UI. Could be Streamlit, could just be some other framework or tool that you're using to build an UI, and then have different options to choose different image processing techniques. Could be a drop-down menu, you choose which of them, and then it's going to apply that on a video or an image. Then we're already starting to build some projects. Make sure that you put your work out there, create a GitHub early on, document your whole process, document your whole journey and so on, because then you also have that after to show people, okay, I have actually built it. You have all the fundamentals, most of them, you have projects, you have some experience, and then after the year, like, you're pretty much ready to get out there. You don't need to spend 5 years just getting theoretical stuff in your university degree. You have no experience, no code, no LinkedIn, no GitHub repositories or anything. You're starting out. You just have to apply to hundreds of jobs and wish, or like basically just pray that you get one. That's not the way to go. Follow this roadmap here. Make sure that you're building all of it up at the same time, and then you're ready to go. Then in month 3, we need to do some image processing and computer vision basics. So we just keep building on top of what we can do with OpenCV. Convolutions, edge detection. So how are we basically just going through the image with convolution? How can we apply different filters? We can have edge detection, morphological operations. How do we process it? What can it be used for in different situations? Often we use deep learning based approaches now for computer vision, but a lot of problems and even pre-processing steps can still be used with, or can still be solved with, traditional classical computer vision methods. Could be morphological operations. I've used that a lot in image processing. Even in 3D space, you can apply any of these techniques here to 3D space as well. So with computer vision, 3D object detection, like 3D space with point clouds and all that, is also a very big part of computer vision. Of course, that's more advanced, but let's start to think about, okay, why is this act like important? Because what's applied in 1D can often be applied in 2D, and what can be applied in 2D can most certainly be applied to 3D as well. It's just adding one more dimension. Then we have some histogram equalization, perspective transformations. So how can we see points and objects from multiple camera views? How do we relate cameras together and so on? Histogram equalization. If we have a dark image, if it's night light image, then we can go in and basically just have all the intensities. So every single pixel in the image will have an intensity. We're going to learn about that. If we have a dark image, we can apply some image techniques. So we basically just flatten the histogram out, and we'll be able to see way more, and even more than the human eye, just from an RGB image. This is some basic image processing and so on. So we're still at the basic level. Then we can start to build some machine learning fundamentals on top of it. Once we get into more intermediate step for computer vision, camera calibration, stereo vision and so on, that becomes a bit more complex. 3D space, depth estimation with AI and so on. But when we have the fundamentals of OpenCV, Python, we know the basic techniques, let's start to build some machine learning fundamentals on top of it as well. Don't just go straight to training an object detection model. I can see so many computer vision engineers out there, even people they have in the CV, that they have trained object detection model, instant segmentation, post estimation models. They have experience in object detection, and that's pretty much it. They have only created projects with object detection. Their main experience is object detection, YOLO and all that. And I can tell you one thing, if you're not familiar with it, it's 2 lines of code. I even have videos here on my channel where you can do object detection in 5 minutes. And most people, like with a 5-year, I'm telling you, with a 5-year university degree, this is not just edge cases or like a few people that I find somewhere here and there. It's actually like most people out there, like most resumes that I'm reading, most experiences that people have when they graduate and get out there. We're talking 5 years in university, and you can do something I can do in 5 minutes with 2 blocks of code. And you don't even have to write the blocks of code, because in the videos I have the Google Colab notebook under the video. You can just run that, take your data set, use the model. It's way more about like building systems, knowing all these different tools, how can you connect them together, build projects, and actually get out there, guys. So this is very important as well. Let's start in month 4, machine learning fundamentals. We have support vector machines, decision trees, random forest. For the machine learning parts, this is not specifically for computer vision, but this is just some classification methods, different classical machine learning. If you're like transitioning from other AI machine learning field into computer vision, you're probably familiar with those, but start to learn how are the models actually like learning. It is based on statistics, these ones. How is a random forest, decision tree, how are they structured, what's going on under the hood with the math, because then you get statistical knowledge, you get some more math knowledge, you have linear algebra as well, probability theory, and you can start connect all of these things together. It's not 100% related with computer vision, but we need to have some fundamentals before we can start like juggling around with all different things. Later on, we'll build more computer vision specific things on top of it, but it's just good to have some fundamental understanding of every single field that we're trying to combine together. For Month 4, we also have some computer vision. So SIFT, ORB, HOG, HOG. This is very good for feature extraction. So how do we find points in our image? Could be like edges, or like could be a corner, could be like every single corner here, like could be a sharp corner, could be some lines, just specific unique points. How do we find unique points in our image, which is called these feature extraction? So we have feature detection, feature matching. We can use that for a ton of different computer vision algorithms and methods. So both camera calibration, we can do homography transformation, perspective transformations, all different types of algorithms we can use feature extraction for that. There's even some AI deep learning based approaches now, but this is just to get into some more immediate computer vision stuff. So we start in month 4 here, we start with the basic machine learning stuff, and then we start to get into the intermediate computer vision stuff as well. Then for month 4, you can build a project with image classification without deep learning. So basically go ahead and use support vector machines, go ahead and take some feature extraction, some support vector machine, very basic algorithms, try to combine that and build an image classification system. We can use deep learning model later on, but it's still very important that we actually know these classical methods. They're still very useful in a lot of cases. Then let's try to build a bit more on top of it. Let's make machine learning a bit more computer vision specific. In month 5, let's start to build some deep learning basics on top of it. This is very good as well. I have a ton of free resources on my channel, but also a ton of other YouTube videos out there. I need to start to learn about neural networks, artificial neural networks, where we have the neurons, how are they connected, what are layers, what are neurons, what are different activation functions, how do they affect the neurons. All these different things. We have badges, we have optimization, we have loss functions. Start to learn all these different terms here for deep learning, convolutional layers, pooling. Convolutional is used for computer vision. We also have the transformers for the large language models, which is also very good for computer vision, but most of the real-time models out there is convolutional based. So it's basically just kernels that we have running on top of our image, finding features. Convolutional layers, very important. Pooling as well. So how do we actually downsample our image throughout the layers to reduce processing time and processing power that we need to handle images? Because when we're talking about deep learning, image processing in general, it's actually like a lot of data. So we could have an image which is like several hundred kilobytes, if not 1-2 megabytes image that we need to process. That is a lot of data. Imagine that we have to process like a 1080p stream, 30 frames per second. That is a lot of processing power. If we both need to do some pre-processing, we need to do some operations on top of our image, run it through an AI model, we need to do that 30 times per second. That's very important to focus on. Well, how do we get the system to run as fast as possible, especially with the AI models and all that? That's something that they're not going to replace. We don't have a large language model that's going to replace running computer vision in the real world in real time, because that's a crazy hard problem and it requires hardware and everything. It's not going to be replaced by AI. Then for that project, let's go in and train a simple convolutional neural network from scratch. You can just go and do it for classification. So you can use the same data set or like find a new data set. You can find on RoboFlow Universe, Kaggle, tons of different resources out there where you can find a data set for classification. Try to implement. You can also just use the MNIST dataset. That's pretty much like just the first project you should get started with when you're learning deep learning and computer vision. It's basically just the numbers from 0 to 9. Train a classifier, have a convolutional neural network, implement a convolutional neural network from scratch, where you have the layers, you have all the neurons, you specify the kernel, the pooling, the striding, and all that you need to do when you train that. The best frameworks, just start out with PyTorch. You will probably figure out, do I need PyTorch, do I need JAX, do I need TensorFlow? You'll probably hear about TensorFlow or Keras. Just go with PyTorch. The most popular, the most supported, bit higher, a bit steeper learning curve, but just go with it. It's the best framework, everyone is using it. Just go with PyTorch. There's nothing to discuss there. Go with PyTorch, learn these fundamentals, start implementing it, and let's move on. So this is very good. And then we can build on more advanced deep learning techniques in month 6, but also start to like get into some of the update section. We start to get into like advanced deep learning techniques, object detection, how does that actually work under the hood. We can get into some camera calibration, stereo vision, so how can we find depth in our image. That's also very important to start to get into, because then we get into the advanced topics for both machine learning or like deep learning and also computer vision at the same time. Then we can combine it, and this is actually where you start to become a real good computer vision engineer. And then we just need the experience on top of it, and you're pretty much unstoppable. You can get out there and build systems around it, then focus on, okay, now you're a computer vision engineer, how to actually get it out there, how to build software systems around it as well. So for advanced deep learning techniques, transfer learning in month 6, focus on the existing architectures. We have ResNet, VGG, MobileNet, EfficientNet. ResNet is pretty much the most popular out there. It's just a feature extractor where you can throw in an image, it finds features in early layers, it downscales it, it finds more and more features. So in the start, it might find lines, corners, and so on as our feature extractors. Then down the line, it will start to combine the features. If we're detecting a car, it might start to find like doors, wheels, windows, side mirrors, and all that. That is like some later features in later layers. And then once we have that, we can also build a head on top of it, or a classification network where we just have an ANN sitting on top of our feature extractor. Then we can do transfer learning, learn about transfer learning, fine tuning, and so on. How can we use an existing base model, which is trained on a benchmark dataset, a pre-trained model. Often you train it on the COCO dataset, ImageNet, and so on. Then you take a model and fine tune it on your specific dataset. Once you get into training, learn about learning rate, different optimization methods, how many epochs, all the different training metrics that you get out as well at the end. So we have precision, we have recall, we have different accuracies, we have all our losses depending on what type of network that you're training, because when we're training our networks, we basically just want to minimize our loss. We wanted to iterate and get better and better over time. We had batch sizing, how many images can we throw together at the same time, process it through a model. We do our optimization, so learn backpropagation as well. That's how all the neural networks and AI models are learning. Stochastic gradient descent, SGD, optimization function. We do a pass of our data through a model. We calculate our loss. We have our ground truth data as well. So this is supervised learning, learn about supervised, unsupervised, and also basically just semi-supervised learning. In supervised learning, we have an annotated and we have ground truth data. We then calculate the predictions that we get now with our ground truth data. Then we get a difference or a loss. Then we take that loss and basically just do optimizations with our math all the way back in our layers again for every single neuron. And then we do a small change. So we basically just change the weights here and there all the time when we're training a model. That is called an epoch or an iteration. Then we can just do a number of iterations, hundreds if not thousands of iterations, and then the model is just going to change the weight slightly to minimize the loss, because once the loss ideally is close to 0, it's actually like predicting exactly what we fed it in the start with our data set. So this is also very important, and then we get into more advanced topics. So this is probably like where you can start out if you already have all the basic understanding. But this is really easy. Like most people, they just skip it. They go directly to train YOLO models and all that, but make sure you have some fundamental understanding. As I told you, training the YOLO models is just 2 lines or like 2 blocks of code. You learn nothing from it. You can use it for nothing. You create a nice LinkedIn demo with a video, but you can't use it in the real world. And you don't know what's going on under the hood, so you can't solve real problems. So try to go in, fine tune a pre-trained convolutional neural network on a new task. Could both be object detection, but also just classification, which is pretty good. Grab an existing model, grab a data set, fine tune it, figure out what are all the layers, all the hyperparameters that we need to tune, and all that. Now we start to get into some of the more advanced stuff as well. So advanced topic for month 8, 3D computer vision. We have SLAM, how can we simultaneously localize and map areas with a stereo camera. Could also be a monocular camera, so a single camera. How can we do depth estimation with AI models? Take a stereo camera where it's basically like at the human eye. You get better depth information in the real world when you have like 2 eyes instead of 1 eye. And then with math, you can actually go in and do some math. You can calculate, okay, how is the object changing, or like a single point changing from one camera frame to the other. You know exactly dimensions and the distance between the different cameras or the transformation. Then you can calculate the exact distance to that point. This is a pretty cool one. There's also SLAM, there's like 3D Gaussian splatting, NeRF, where you can just capture a video around an object. It's gonna do a bunch of map and train a model that can go in and do 3D reconstruction. There's structure for motion, do feature extraction or like feature detecting, feature matching across multiple camera views. Then we can go in, combine that, minimize the reprojection error, which we know from our camera calibration. This is also very important, have all of it covered on my YouTube channel, but this is how we go from 2D space into 3D space. This is a lot more advanced, a lot more technical, hardcore and so on, especially if you want to apply it to real world use cases. It will take longer. It's more processing that needs to apply, but the techniques under the hood is also significantly harder. Optical flow, feature matching, how are we matching features from one frame to another or even multiple views. Then you can combine that into a 3D space. You will start to get point clouds. We can also use optical flow. You should explore optical flow for the advanced topic as well. So how are we tracking key points in a video, for example? So if we have one key point, we detect that. How is it moving from frame to frame? Let's say in a video. That's also very good. It's just tracking how are your pixels moving in the frames. Vision transformers, the attention mechanism, this is getting more and more popular, using the transformer architecture for computer vision as well. It's starting to become faster, but previously it was too slow to run images because it's just so much data that we need to process at the same time. For this project, do 3D reconstruction from stereo images or just single images, could be NeRF, 3D Gaussian, but try to go in and do it with structure for motion. Look up structure for motion, get familiar with it, because even the 3D Gaussian, NeRF and so on, they use structure for motion to initialize the point cloud, and then they do AI optimizations on top of that. Month 9, now we have the advanced topics in deep learning, computer vision, everything that we need to become a computer vision engineer. Now we need to know, how do we actually get the models out there in the real world, providing value, because we can't just sit in our Jupyter notebook and don't know how to get our models out there. This is where most people is failing. They don't know how to deploy it. They don't know how to actually get them out there, build software systems around it. As I mentioned, take 5-year university degree, no experience, no work out there, no opportunities. You don't know how to deploy models. You don't know how to build software systems around it, because in university they teach you all different stuff that you don't need. You need the fundamentals. All the stuff here that I have in a roadmap, most people will probably say you can just train a YOLO model and learn how to deploy that and build a system around it. Yes, you could do that, but you can't navigate. You don't have the experience to do all different types of projects as a computer vision engineer. So this is still a lot of the fundamentals that you need to know, but in university they teach you 2, 3, 4, 5 times more stuff that you don't really need to know to become a computer vision engineer. But they're also not teaching you projects, how to get out there, get opportunities, use the new AI tools to make yourself more efficient and so on. Like, they're actually like saying that if you use large language models, if you use ChatGPT and all that, you're cheating. You're just cheating to become a better version of yourself faster and learn faster. So that's why a dedicated roadmap, stay dedicated, stay consistent, have mentorship is so much better than a university degree. Model deployment and optimization in month 9. We need to get familiar with different optimization frameworks. ONNX, very standard format to convert your model into. Then we can use like TensorRT, start to figure out hardware. When you're a computer vision engineer, we need to work with cameras. The focal length, how does that affect it? We have different lenses, we have frames per second, what image resolution do we need, what hardware do we need to process it, and so on as well. So make sure that you know CPU, GPU inference, know the hardware technical details, try to run it on edge devices, try to run it on cloud, CPU, GPU, just get experience with that, get experience with CUDA, NVIDIA's different frameworks, all different types of optimization frameworks, OpenVINO for CPU, Intel CPUs, we have MPS, and some other different frameworks, ML Core for Apple, we have NVIDIA, TensorRT, DeepStream. All these frameworks are very good as well when we want to get out there, do model deployments and optimizations. So TensorRT, just by doing a TensorRT optimization compared to the raw PyTorch file which we have our model in, can actually like do 3, 4, 5x inference speed without losing any accuracy at all, just because we're running it on an NVIDIA GPU and the model is optimized specifically for that. We can even go in and do quantization, definitely look that up as well. So how do we go from floating point 32 to floating point 16-bit or even int 8? So just going from 32 bits to 8 bits, that's actually like 4 times less memory. Our model is basically just 4 times smaller, so it can run faster, but also consumes less memory. We don't really lose much accuracy, especially if you only go from floating point 32 to 16. So this is also very important to know, and most people don't know that, even computer vision engineers with a ton of experience. Deep stream, how do we process, how do we synchronize images, how can we have multiple cameras running at the same time, synchronized, basically just set up the whole vision pipeline. Most people don't know that. There's people like 3, 4, 5 years out there just working a job after the university degree. They have no idea about any of these things because they're just some very senior guys that is doing all that work. That's where the fun is, that's where the value is, that's where the money is. So make sure you get there as fast as possible as well. Haven't really met any people that is saying, I don't want more opportunities in life. I have a good job, I don't want a single other opportunity in my life. Deploy computer vision model on fast API on hardware, so you can run either CPU, DPU, whatever you have available. Try to deploy it with a backend framework like Flask or Fast API. Build an endpoint around it. You can send a request to it. You get a response back with the predictions that the model is doing. This is also how you build it in a real computer vision and software system. Or if you're just a computer vision engineer, want to expose it to your front-end team, back-end team, another department, and all that, or even another project, then we need to build like an API around it, unless we run it locally or we just have a very dedicated system, but we still need to know how to react, like deploy it. This is so important. So learn fast API here, start to get familiar with how does it work in the backend, how do my work actually get out there, how can I deploy it on different types of hardware, both cloud, local, or even on your own local machine, edge devices. Start to deal with dependencies, because once you start to set up systems, you run into a lot of dependency errors. Check out Robeflow, they have some really cool stuff for running at least object detection, instant segmentation, and all those models. So this project, deploy computer vision model locally with Flask API, expose an endpoint, and then run predictions with your model. Then in month 10, we can go in, act like just build a full-scale system. Could be medical image analysis. Some very cool ones is sports analytics. So that could be soccer, football, whatever sports, tennis analysis. You detect all different key points on the field or on the tennis court. To take the corners, you can set up line detection, you can detect the players, post estimation, how are they moving around. You can do homography, perspective transformation, so you get a bird's eye view of all your detections. This is what you should do in month 10. Choose an end-to-end real-world computer vision project where you can combine all the things that you've learned, and remember, put all your work out there. Make sure that you document it, every single step, not only the results. You can document all the thought process, all the things that you're testing out on the way, and just explaining how do you act like solve a problem from a project statement. So this is a very good one. Focus on data collection. Start to figure out, how do I collect data for a computer vision project? How do I train the models? How do I fine tune them? How do I make it even better? How do I extract the results, use it for a real world application and project, build a software system on it, and then deploy it. This is an end-to-end computer vision system. You can apply any use case. Could even be that you're into whatever field. It could be music, that you want to do something with computer vision. Could be horse riding if you're into that. Any field that interests you, you can build a computer vision project around it. So I'll definitely recommend finding something that interests you and then spend this month here just combining all of it together. Month 11, and this does not only apply to month 11, but pretty much just throughout your whole coding career. Start to go in, Kaggle, like compete in different Kaggle challenges, go out there. Also open source contributions, different open source frameworks. I have a ton of different open source repositories on my channel as well, specifically for computer vision. YOLO 3D, I have camera calibration, all different types of repos that you can contribute to as well. You also have Autolytics and all those. Make sure that you do open source contributions. You start to learn how to actually like implement features, how to look into the code structure of larger code bases, contribute into it, as an individual, this is very good experience as well, and this is what most people are lacking. If you just give some task to a new junior engineer coming out there, they have no clue. Maybe they can solve the task, but have no clue of how to integrate it into the system. Most people that graduate, like, they don't even have any clue about Git, how Git works, how deployments works, how pretty much everything, like Docker, how do you Dockerize your code, Kubernetes, how do you scale your system, how do you create a Docker file, requirements file, freeze all the different versions. It's actually mind-blowing, but people don't know this when they get out there, especially in the computer vision AI field. Maybe if it's just software engineering in general, they know that, but a lot of computer vision engineers, they don't know GitHub, Docker, and all these tools here. And I even learned it very late on as well. So make sure that you actually do this, because your teachers, the professors on university, they're not deploying software systems. They're not creating full-scale software system and so on, unless you are at MIT, Stanford, and so on. But 99.999% percent of you guys out there, like, you're just in a standard university, just as I was in a standard university. Teachers, they're not the best. You can find way better resources online. And also, those teachers, they're teaching for a reason. They're not building software systems. So one recommendation that I have is that you shouldn't really learn something from someone who's not where you want to be. It's the same as business. Like, if you're going to business class and so on, some guy like driving around in Toyota is teaching you how to build businesses. Like, if he really knew how to build businesses, like, he would probably not be teaching, or at least he will be teaching at a very good university. He'll probably like drive around in something else than a Toyota. It's just a whole different mindset and so on. Like, I even have teachers in my university, they were just like straight out admitting they were just there to just like chill out, write emails, drink coffee, and just do some chill research, and they had to teach just because they had to teach. That's not the best teachers out there, guys. Don't waste 5 years on that. Make sure that you have the correct mentorship, follow what's going on in AI, and have a real roadmap from someone that cares. This is very important. Contribute to different open source frameworks. This was kind of like going down the sideline. Let's go back here again on the main road, but the other stuff was very important too. So contribute to OpenCV, PyTorch, YOLO repositories. Throw it out there. That will also put your work out there. You'll start to get into it. Write documentation, read documentation, create your own GitHub projects. Documentation, personal website. That's the project for month 11. We start to get into more real world stuff. In month 12, review, specialization, and then prepare to get out there. Prepare to get into job interviews. Have the correct mentorship. I even have that inside my AI career program as well. How to do the job preparation, how to solve assignments that you get, often in computer vision, AI, and so on. You get a take-home assignment. We go through salary negotiations, how to get credibility, basically just how to talk with recruiters, technical teams, how to solve these problems and just ace these interviews, because it's often determined by 1 or 2 calls. Like, you have 30 minutes, 1 hour to convince someone that you're the best one out there. You should have a high salary, you should get opportunities, you should have managing roles and all that, you should get good salary. You need to know what you're talking about and what you're doing if you really want to ace it. So yeah, review the call algorithms, math, deployment, pipelines, and so on. We need to train up for it. It's not a sprint. It's like going to the Olympics or like training up for a tournament in sports, which can't just like lay on the couch all day long and then expect to be able to go out there and compete at the top level. Sports, it's the exact same thing in coding, in tech, in any field out there. If you want to be the best, we don't have to do much. We just have to prepare, we have to practice, we have to train, push your brain, push your limits, and so on, and you will become a better version of yourself in any possible way. Specialize in a specific area, could be object detection, 3D, computer vision, augmented reality, virtual reality, robotics. Computer vision is also a very big component in robotics. With object detection, just promise me, you guys, don't just say on your CV that you have experience with YOLO and train object detection models, because people looking through all that know it's just 2 blocks of code. It shows nothing. So don't even, you can mention it, but it shouldn't be like the main part that you can do. And that's what I'm seeing in a lot of resumes. Prepare for interviews. Coding machine learning topics, project discussion, all that I have inside the course as well. And then make sure that you're ready to demo your projects. The best thing that you can show in job interviews is the projects, the work that you have out there. I have my LinkedIn, I have my YouTube, I have my GitHub. Everything is structured in the best possible way. I have a good camera, I have the modern day suit, good microphone. I come out there, I know what to say and so on from all the experience that I've gotten. I've worked on a ton of different projects. If you just combine all of that, like I'm just gonna blow out anyone else that's going to basically like apply or be in that job interview, they will get a very good first impression of you and you will stand out. It's not much that you don't need to do all this, but if you have a good GitHub repo, if you have a few projects, if you take initiative, you're already doing more than 90% of the people, or even more, probably say 95 to 98% of the people getting into job interviews. So stay hands-on, apply the theory immediately after the project. Sometimes just take the projects, even learn, okay, what do I actually need? What tools do I need to solve this problem? And then break it down in that way as well. We need to have a fundamental understanding before we can do that, but try to solve the problems in that way later on. Use GitHub, learn GitHub, document your work, and basically just have version control. Join different communities, get your name out there, build some network, build some friendships. Maybe get people that can be on your own journey as a community part of so on is also very important. Cloud resources, Google Colab notebooks, you have free GPUs out there, very good. Use your own local environment, try to use CPU, GPU, all that. Build a strong portfolio, have good 3 to 5 well-documented projects. Consistency is more important than intensity. This is pretty much what I'm going to end off with for this tip. Consistency is the most important thing. I'll say my only advantage that I have over most people is that I can stay consistent for a very long time. That's why this YouTube channel, my courses, everything just keeps just increasing, keeps growing, and keep getting more up and more opportunities because I'm just staying consistent. Even sometimes when I don't want to do it, you just still have to do it. At the end of the day, the hard days are gonna be the most fun days, and also the days that you look back at. You can see some of the videos on my channel. The first ones are just sitting in a 1-bedroom dorm with my roommates and all that, coding, building all up I have today. Those are good days to look back to. It's worth it. Get through it. It has to be hard. You have to push your brain. You have to push your limits to be able to grow yourself, make you become a better version of yourself. If you follow all these different things, I promise you, it will not hurt you. You're only going to be a better version of yourself in so many different areas. And that's worst case scenario. Then just imagine if you complete this, if you stay consistent and implement all these things here, what it can unlock for you. You have a strong understanding after a year here, maybe even 8-10 months. You can probably do an 8-10 month if you're starting out early on. If you're consistent, put in the time, but also have some understanding and fundamentals with coding, tech in general. When you're starting out, 8-10 months, you can have a strong understanding of computer vision, deep learning deployments, and getting projects and software systems out there. Have a portfolio showcasing real world projects. You're ready for getting out there with job applications, interview as a computer vision engineer. Everything is fresh. You have everything up and running. You have recent understanding, recent knowledge. You can go out there and apply. So this is the final outcome after the year. You'll not be in a worse situation, only better. Everything here, I'm helping people out inside my AI career program. A lot of people is joining now to get the mentorship, basically just to be able to navigate this whole world with AI, what direction to go, what degree should I take, can you help me out with this, how do I solve this specific problem, what do you recommend, all these things here. I have the mentorship program, all technical courses are available. We have a nice community with all the guys. Some of them are helping me out with freelance work as well, because I can see how dedicated they are, what skill set they are, and then I can hand out projects to them as well. That's also a very cool factor of the AI career program. Whether you're starting out from scratch, transitioning from another tech field into AI or computer vision, pretty much doesn't matter what state. I'm going to help you out on your own journey to get where you want to be, because the most important thing is to have a map. This map here is gonna make you a computer vision engineer in less than 12 months. Stick to it. Hope you're going to do it. If you have any questions, like, drop it down in the comment section, reach out to me, join the AI Career Program. Let's ace this together. And I promise you, if you stay consistent, if you stay dedicated, you'll become a good computer vision engineer. Some of the best out there, especially compared to new people coming out there with just a degree. Hope you learned a ton. This is a very long video. Make sure that you go through it again. I went over all the topics, the project that I need to create, a full breakdown month for month, but even I explained some of the technical details on the go, why it's important to learn how do we break down problems, but also what tools should we use, why should we use it. That's also very important. Make sure that you understand all of it, have the roadmap, understand every single thing of it, and then get started. Don't just get started without knowing exactly what you're doing, because again, then you're just navigating around in an unknown environment. Hope you learned a ton, and I hope to see you guys in one of the future videos, and then I wish you the best luck on your computer vision engineer journey.